All right, today I'm going to go over and explain the weather station model lab. To use the information they give you to complete the different station models. Some of them you're going to be interpreting, and some of them you're going to actually be drawing. So here we go. At commercial airports throughout the country, the weather is observed, measured, and recorded. In New York State alone, there are over a dozen observation sites. These stations record temperature, dew point, cloud cover, visibility, height of the cloud base, amount of precipitation, wind speed, wind direction, just to name a few. Whew. The measurements are made every hour at every station around the world. This is a very large amount of data, which can be very useful in predicting the weather. The challenge is that a large amount of data needs to be communicated to every weather station in the United States. Because of the lack of space on weather maps, the weather information needs to be coded. In order to do this, the information needs to be highly organized and a standard throughout the country. By using station models, the data can be represented by a symbol or a number, and its meaning is easily understood by where the symbol or number is placed on the station model. Through this lab, you will learn to understand station models used in meteorology by coding and decoding a variety of stations. So this is kind of like the SI units of weather. The symbols that we're going to be going over and the station models are going to be the same everywhere. The only difference that you may see is whereas where our temperatures are Fahrenheit, another countries are going to be Celsius. But everything else is the same information. All right. So here we have our station model. This is what it's going to look like when you see a station model. There's a lot of information crammed into a small little picture. But everything in this picture is going to be the same in every picture as far as where it's at. So this top left corner is always going to be the temperature. Now we're in the United States, so when we read these, it's going to be our temperature in Fahrenheit. Directly underneath that is going to be the precipitation and visibility distance. There may not be any precipitation marks. There may not be any visibility marks if it's all clear. If there's no precipitation or the skies are clear and you can see with no problems. So there may not be information there. That just means it's clear skies. Directly underneath that in the bottom left corner will always be the dew point. So when we look at these, we want to pay close attention to the temperature and the dew point because we know the closer they are, then the higher chance there is of precipitation actually falling from the sky. Of course, the middle mark, those symbols will tell you what kind of precipitation it is, if there is any. All right, in the top right corner, this will always be the barometric pressure code. Now, these three numbers are not the actual pressure. We're going to learn how to decode that number to the actual measurement. But this is where you'll find the air pressure coding. Directly under that is the trend. So this is how the air pressure is changing over the last 3 hours. So if we want to know what it was 3 hours ago, we can use this number to predict or calculate that. If we want to know what it's going to be in 3 hours as a prediction, again, we can use this number. And then directly under that is the amount of precipitation in the last 6 hours. So if we're looking at this model, this is saying that we've got a quarter of an inch because we're in the United States. We use our arrogant measurement system. So this would be a quarter of an inch in the last 6 hours, and it's inches of moderate rain. So we got some rain. We don't have, well, no, that's, snow. I'm sorry. That's moderate snow. So we have a quarter inch of snow has fallen in the last 6 hours. The circle itself will tell us the cloud cover. Based on how this circle is colored, it will tell us either as tenths or fourths, depending on the coloring. It's either going to be in terms of tenths or quarters. And then the last bit of information, of course, is the wind direction. Remember, this is going into the weather station. So that means that this is a southwest because that's where it's coming from. It's going into the station from the southwest. So that means it's a southwest wind. And then these flags at the end will tell us our speed. In the United States, we use knots, which means nautical miles per hour. So the large flag is 10, the small flag is 5. So this tells us it's going 15 nautical miles per hour. So a lot of information crammed into a very small diagram. So let's start breaking this down a little further. Now, I told you that the air pressure code isn't actually those three numbers. When we're dealing with air pressure and we're trying to decode that value, we have two situations. If the number is going to be 500 or more, so if the value is 500 or more, we're going to place a 9 in front of that number. We have an example right here. So we have 588. We put a 9 in front of that. And then we also, the last digit is a tenths place. So we put a decimal. So that 588 is code for 958.8 millibars. That's a rather low air pressure. That's something that we like. Now, if the number is less than 500, we're going to put a 10 in front of that code. And again, the last digit is a tenths position. So for example, if we see 091 as the code for air pressure, we're going to put a 10 in front of that number. So we have 1009 and the last number is tenths position. So 091 translates to 1009.1 millibars, which is a high pressure. So that's the rules for our calculating the air pressure based on what we see. If it's 500 or more in that spot, so 500 to 999,999, we're going to put a 9 in front of it. Last digit is tenths. If it's less than 400, so 0 to 499, we're going to put a 10 in front of it, and then we end up with the last digit is tenths place, and that's our measurement. Now, when we're predicting the weather, we're using that trend. Remember, this was 3 hours ago. So if I want to calculate what the weather pressure was 3 hours ago, I have to do the opposite of the sign. Because the sign says it's going up, then 3 hours ago, I have to subtract that amount. If the sign says it's going down, then I'm going to do the opposite and add. So for example, if we have the symbol of 12 plus 12 as our trend, and we want to know what it was 3 hours ago, that 12 is actually representing 1.2 millibars. So we have to subtract 1.2 millibars from our actual air pressure value. So let's say our air pressure value was 958.8 millibars. I would subtract that 1.2 from that, and that would give me what the pressure was 3 hours ago. Now, if it has a negative, that means that the pressure is going down. 3 hours ago, it was higher. So again, it's that two-digit number is a ones and a tenths place. So for example, we have negative 24 right here in our instructions. So that translates to 0.24 millibar decrease. So since it was decreasing, that means we have to add the 2.4 millibars. So we add that to our value. So that's how we handle the air pressures. Again, this information is exactly the same as what you're going to see in your documents. You'll get everything you see and more, because you will have more. Your work actually has more problems than what I'm going to show you in this lesson. Now, temperature and dew point are always reported in Fahrenheit. They may need to be converted to Celsius. I will show you how to do that conversion. It's very simple, so no need to freak out. Wind direction, we already discussed the wind direction is going into the circle, and then we name from where it's going into, so where it comes from. And of course, the flags tell us our speeds. One thing that I didn't show you on there, a triangle on the flag is equal to 50 knots. Of course, here it has a knot, which is a nautical mile, is equal to 1.85 kilometers per hour, or 1.2 miles per hour. We're just going to put everything in knots. Keep it simple. All right. Cloud covers. So remember I said it comes in tenths or quarters, depending on how this is colored in. So here you can see all the different readings that we get for that circle, how it's colored. So an obstructed view is when the observer for some reason couldn't see the night sky, or you can't see it. And then clear, of course, is pretty simple. It's clear. You can see for a long way. So if we have a circle with just this bar colored in, that's 1/10 cover. The next measurement is a quarter, and it looks exactly like a quarter slice of pie. Then 4/10 is the quarter with the line straight down. And then 1/2 is pretty straightforward. It's half the circle. Then 6/10, just like from 1/4, we drew the line down. 6/10, you're just going to draw the line across. And then we go to 3/4. And then 9/10 is the opposite of 1/10. So it's colored in with the exception of that bar. So it's the exact opposite. And of course, overcast means that there's 100% cloud cover. And again, obstructed view. This means that for some reason you can't see the sky. You're inside a building. For whatever reason. There could be, if it's dark outside. So if there's an X in the circle, that means it's an obstructed view. It doesn't mean that it's 100% cloud cover. It doesn't mean it's overcast or 9/10 coverage. It just means the person who's doing the reading could not see the sky for some reason. So there's no data to represent it. All right, precipitation. Of course, this is any kind of water that falls out of the sky. We've gone over this. So we have different symbols, and we can actually combine these symbols to make them mean different things. So anytime you see a circle or a dot like this, that's your rain. The upside down triangle means showers. The pointing up triangle means hail. The asterisk or star, that means that we have snow. The little apostrophe is drizzle, real light, kind of coming down constantly. A triangle with a dot in the middle means that it's sleet. That means it's freezing rain. Our equal symbol means it's fog. And then this really cool one, this means thunderstorm with lightning. So this is a thunderstorm symbol. Now I said that we can combine these. So we have rain. That's our symbol for rain. If we put two of them, like so, now we have moderate. So this would be light rain. This would be moderate rain. And then If you have 4, that is heavy rain. I don't think we have to worry about those as far as today's assignment. And likewise with snow, same thing. One is light, the 2 stars. So here we have 2 stars. That is moderate snow. And then 4 stars, which this is the one you guys like to see in the wintertime during school. 4 stars is heavy snow. We can also designate showers with specifics. So we can have snow showers. So if we put the symbol for showers and we put the symbol for snow, this tells me that it's snow showers. Pretty cool, huh? We can combine the types of precipitation with our thunderstorm, because sometimes we just see the lightning and hear the sound, and in the summertime we call that summer heat as a thunderstorm. But what happens when the thunderstorm is where we're at and it's raining? Well, the symbol would be the thunderstorm with rain above it. And if you're lucky, and some of you will actually see this, especially if you guys move up north. I saw it a lot growing up in Portland, which is just under Portland, Oregon, over on the west coast, up north of California. Sometimes there's also this thunderstorm with snow. Pretty cool, huh? So we can use these to give more details. All right. So we're going to move along here. So the first half of your assignment is you're going to decode the weather station model. So here, station 1, this is exactly the same one that you have on your paper. Mine is just side by side. Yours is the station above and then the chart below it. So the first thing that we have to figure out, well, it wants to know the temperature in Celsius. Well, we don't have that because we're Americans. So this is the Fahrenheit. So our temperature in Fahrenheit is 65 degrees. And I know that because that's this symbol right here. There's nowhere for, we don't have to worry about the dew point as far as this goes. The next thing it wants to know is barometric pressure. Well, let's do the temperature Celsius first. So to find my temperature in Celsius, I'm going to do my Fahrenheit minus 32, and then I'm going to multiply that by, let's see, this is where I always get a little off. Let's see, wait 1 second. 1 second. All right, so it's Fahrenheit minus 32 times 5 ninths. And we can do this real easy, putting it in the calculator in one simple step. So for our situation, our temperature is 65 degrees. So we're going to do, in our calculator, 65 minus 32. Then you're going to do times, and then in parentheses, 5 divided by 9, and you're going to get your answers. So 65 minus 32 minus 32 times 5 ninths. Come on. 65 minus 32 18.33 degrees. There we have it. The magic of editing. So anyway, we put this in our calculator exactly like this, hit enter, and you get 18 point and a whole bunch of threes and then a 4. So we know that's a irrational number. That means it's it's a repeating, non-terminating. So we're just going to put 18.33 degrees for our Celsius. All right, barometric pressure. So here we have our barometric pressure code, 998. So I'm going to put my 998. I know that right off the bat, that 8 is a tenths place, so I'm going to put my decimal point. And now my rules. Is it greater than 500 or is it less than 500? If it's greater than 500, we add a 9 to it. So it's greater than, so we're going to put a 9 right in front of the whole number. So now our barometric pressure is 999.8 millibars. Okay, precipitation type. We have this symbol right here. That's the symbol for fog. So we're going to put that right here, fog. Our cloud percent of sky covered by clouds, we can put 100%. We could put, let's go back and check our symbol. Overcast is another option that you can put in there. So 100% or overcast is our options on that one. All right, our wind direction. Remember, wind direction is where it is going, coming from, and it's entering into the station. So it's coming from here. We know this is south. So we know that our wind direction for this model is south. It's a southerly wind. Mr. Anderson doesn't know how to type, does he? All right, our wind speed. Of course, it's already got knots here, so like I said, we don't have to worry about converting that. But we do know how to know how to count them. So each one of these has a value. The long one is 10, the short one is 5. We have 10, 20, 5. So our wind speed for this station model is 25 knots. And here comes the next big weird thing we have to calculate. Is what was the air pressure 3 hours ago? So we look here, it's -30 is the trend. So that means that it's going to be 3.0. Now, if it's going down, the opposite of that is going up. So 3 hours ago, it was more. So in this situation, we're going to add our 999.8 plus 3, and we're going to get a whopping 999.8 plus 3, 1002.8 millibars is what the air pressure was 3 hours ago. Again, this is the tricky, the air pressure is the tricky ones. It's going down by 3.0 because these two digits, that's a ones and a tenths. Since it's going down, that means 3 hours ago it was more than what it is now. So that's how I know I'm going to add. You do the opposite, and that's what we get for 3 hours ago. So this is how you interpret the symbols, and you read this. If there's no precipitation here, where it says precipitation type, just write none. There is none. If there's no change, just write no, or the same. You can put the same value in. So again, you're going to read these and you're going to fill it out just like I just did. Now, the next thing you're going to do after that is you're going to draw the symbols. So here we have on the second part, this is the first one on your second part. So we're looking at Rochester, New York. So in the chart below, you find the meteorological data that was taken at several different New York state airports. Use the data to create station models for each city listed below. So, okay, here we have Rochester, New York. We're just going to go across this and put them in right here on our little circle. So we know that temperature is always going to be this corner right here. So boom, temperature. We know that dew point is always the bottom right under temperature. Boom. Direction, southwest. Remember, this is where it's going into the thing. So this is where it's coming from. So never eat sour watermelon. So southwest would be there. So I have a southwesterly wind. It's telling me 16 knots. So I've got a large one for 10, a small one for 5, and we're done. That's how we put it in. We don't have a 16th. It's either 10 or 5 50s in those increments. All right, air pressure. This is where it gets weird. When we write this air pressure, this is the decoded version. Remember, we either add a 9 or we add a 10. So we're going to drop the 10 and we're going to get rid of the decimal point. So our pressure, 169. That's the code that goes in there. Because if we look at our rules going the other way, we put a decimal here and we add 10 to it because it's less than 500. All right, our sky is 50%, and when we fill in the sky, it's always going clockwise. So that would be my 10, 1/10. If I color this in, that's the quarter. So we're going to color in the clockwise. We go clockwise on this. So that's 50% sky cover, weather present, precipitation. That's the little symbol that goes here. It says none. We're done. That's it. That's all you got to do. Before I send you off to do your work, I want to go a little bit more about the air pressure. So if I had an air pressure of 9, 5, 4.8. So in this situation, our air pressure that we have is 1016.9. Remember, we're just keeping the last 3 numbers. So here, we X'd out our 10. Here, we're only keeping the last 3 digits. So we're going to X the 9. So our code for that would be 548. So again, when you're translating the air pressure into the symbols for the model, you only keep the last 3 digits of this. Keep the last 3 digits. That's it. It's the last 3 digits. So that's how you're going to draw these. Of course, if you have any questions or you need some help, 3 times a day, Monday, Tuesday, Thursday, and Friday, I'm available on Zoom Meet. You go to the little, on the home page, you go to Zoom Times, and it'll tell you you'll have the join here. You click that and you use that passcode to get in the waiting room. And I'll get you in as soon as I can. If I have people I'm working with, you may have to wait. Just be patient. Sometimes I may not see you right at the minute. Exit, join back in so I can hear the little announcement. But this is how we read and draw weather station models. You're going to have to practice these. You're going to have to know these symbols because you will see these on a test in the very near future and at the end of the year. So until then, I will see you online.